Hello, good morning, good evening, good afternoon. Welcome to this very interesting webinar interactive discussion on non-GSO satellite technologies, particularly for connecting the unconnected. This is it's a new innovation, and I think India can particularly benefit from us because of the huge unconnected population that we have. We have in India a population of 1.3 billion people, maybe 1.35 now, and it increases every day. And we are still many areas which are still unconnected. Many people which are still unconnected. Although we have about a billion plus mobile and telephone users, but even then there is a large population which is completely unconnected and not being able to use uh, internet or voice connection or any kind of connectivity. So hopefully the Leo will bring us there. Today we have a very packed agenda. We have very eminent global personalities on the stage here. We have, if you can see us, Mr. Tilak Raj Dua. He's the chairman of the ITU-APT Foundation of India. Uh, he also is the Director General for TAIPA, which is the body that manages or coordinates all infrastructure providers in India, including I don't know how many, maybe a million towers or more than that, and he will talk about this. And he does a fantastic job of at TAIPA as well, and he does work with the IPFD very closely. Uh, we have Mr. UK Srivastava. He is the head of the Telecom Engineering Center as well as senior DDG of the DOT. Until recently, he was with the TRAI, Telecom Regulatory Authority of India, as a principal advisor mobile network. And now he is heading the most important department in the DOT, which is the TEC, which sets all the standards and provides all the technical inputs to the government of India. And he's been in news. In fact, today he was in big news because of the 5G work that is happening in the PEC. We have with us Mr. N.K. Goyal, who is Chairman Emeritus of FEMA, President of CMAI, and long list of association that he heads. He's a unique personality in the Indian telecom sector, and we call him ever present. He's there everywhere. He kinds of looks after the telecom manufacturing in India. Of the guests, we have Miss Laura Rabetti. She is based in Geneva and very frequent our host when we go there for the ITU meetings. She has worked with the Inmarsat and is now with the Telesat, and I think we will have during the seminar introduce Telesat. Along with him is Manik Vinakota, who is based in Canada, and I'm so sorry it is too early for you, Manik, but it's great that you joined us here on this panel, and he is based in Ottawa, Canada, and is again head of the market development for Telesat. We have Tony Azarelli here. Tony basically is based in UK, London, very frequent participant in the ITU meetings, in all the satellite forums. He is also been and is currently the vice president of market access for OneWeb. As you all know, OneWeb was very recently went through difficult times and was finally acquired by British government and Bharti Enterprises, owned by Mr. Sunil Mittal. So India now has a vested interest in OneWeb. So we brought together these two biggest Leo constellation here, so that people here, particularly from the government and industry, can understand where we are going with these two. And we have Chris McLaughlin, I suppose I speak the name correctly. He is the head of the government affairs for OneWeb, again based in UK. So this is the panel we have today. Our agenda will basically run for about 1.5 to 2 hours. We will start with the opening address by the chief guest, Mr. UK Srivastava. Before that, I think Mr. Tilakraj Dua will provide a welcome address. So over to you, Duaji, for your welcome address.
Good evening, everyone, and very warm welcome to our foreign experts, Laura, Tony, Chris, and Honorable Mr. Shri Yukesh Swastha. ये हमारे गुरु जी हैं सैटेलाइट में अभी कभी ये मोबाइल की टोपी पहनते हैं आई एम जस्ट टॉकिंग इन हिंदी फॉर अ लिटिल वाइल सो Mr. UK is a master but he's been guru in the satellite technology because if I remember correctly he was working for more than 5 years in satellite I think am I correct sir. Okay, I think very warm welcome to Manik, Mr. Goel, Chris, everybody. It's a very, I think, apt subject which has been chosen today. I am not taking much time today. We have assembled here for an interactive session which is use of NGSO satellite technology for connecting the unconnected. As Mr. Bhatia rightly said, we have a huge number of the unconnected people still in this country. So therefore, this is the most apt subject which we are going to address. The word connectivity does not always mean that it is voice connectivity, but essentially voice along with the broadband connectivity is yet to reach the rural masses which are still unconnected. And if you look at the national digital communication policy, and very widely and lays an emphasis on the satellite part of this, which has three verticals: Connect India, Propel India, Secure India. In the Connect India, there's a complete chapter on this, which is strengthening the satellite communication technologies in India and optimize satellite communication technologies in India, including developing an ecosystem for the satellite communication. This is a very great emphasis which has been given in the National Digital Communication Policy, which was notified by the central government in November 2018. And now, just a little bit of why do we need it, where do we need it, how is it going to help the people who remain to be connected. Satellite communication India has played and will continue to play an active role in providing high speed access to gram panchayats, mobile coverage, and also the delivery of e-governance services to far-flung rural and remote areas where terrestrial connectivity is still unable to reach. Terrestrial connectivity, which means through a mobile broadband, is feasible and economically viable to deploy as far as the urban areas are concerned. However, when it comes in varying topographies and vast stretches of the rural and the remote areas, the cost for providing terrestrial connectivity many times it goes 10 to 20 times. Therefore, it becomes economically unviable to reach the massive unconnected population. So, therefore, to top it all are the huge challenges which are posed due to the if I have to connect through terrestrial, which is now I am doing it, one of the biggest challenge comes is the right of way challenges. Availability of land, availability of the duct, available connecting, and the many local bodies coming into picture is a humongous task. Therefore, the solution to reach these unconnected, the rural guys is only through the satellites. Now, in this context, we, along with Mr. Bhatia, who is spearheading all these technical activity, are very, very committed to the progress of the satellite communication in country beside the terrestrial one. Now, little bit more with the advancement in satellite technologies, which is again a part of the NDCP, including the more recent NGSO system, which allow for very low latency application. It is possible to deliver quality and affordable broadband to anywhere, everyone, where these satellite technologies will complement GSO satellite system and current ground-based services, which will fully support the government's forward-looking vision of the digital India, removing the digital divide and providing broadband to all and connect the unconnected. The rapidly increasing use of the non-GSO orbits, such as the medium Earth orbits, MEO, and low Earth orbit LEO, which represents an important innovation in the satellite technology and a potential breakthrough in connecting the unconnected so that they too can reap the benefits of today's digital economy. Satellite connectivity is very important even for the aviation and maritime sector that operate aircraft and vessels that can be put out of reach when they get out of reach of the terrestrial network during their journey. The satellite communications using non-GSO satellite have the potential to serve the rural community and bridge the digital divide through a mobile backhaul, through a rural broadband connectivity, to a urban broadband connectivity, to a remote connectivity, aeronautical maritime connectivity. Now, the space-based connectivity is helping make smart cities. Now, I'm coming back to usage with the smart cities. Space-based connectivity is helping make smart societies a reality across all sustainable development goals. There are many sustainable, as we call them SDG, including the intelligent support, the transport system, e-governance, tele-education, e-health, e-logistics, smart energy, smart agriculture, so on and so forth. As we are very fortunate today, we have with us Mr. UK Srivastava, and I would like to seek his support to allow for a timely introduction of these innovative services under which directly come under his regime now, development of a suitable regulatory framework for NGSO in the KU and KA band, which would also require modification to the some of the interface requirement document on the VSAT and which will allow for NGSO maritime and aeronautical provision in India. Such regulatory framework, which does exist in the other countries, will also help if this is also made available in this country. Now, this is high time that the satellite technology, especially the NGSO based satellite technology, come out much more aggressively in partnership with other technologies. This will also bring in more competition, affordability, spurring private sector investment in this sector and help replicate the success in this sector. Now, I'm just going to bring it out that not only in India, probably the world over, we have the international experts with us. There are organizations in the private sector also which are in satellite technologies in a very big way. All the top economies of the world, that is US, Canada, Western Europe, Japan, Australia, Brazil, use broadband from communication satellite. As per the available data, which US, which is one of the most wired broadband country with almost close to 80% fiber connectivity, has the highest deployment of the satellite-based broadband with over 4 million, as I understand, 4 million terminals deployed. For rural residents in the US, for example, satellite internet broadband is viable internet to mobile or fixed line network. Demand for satellite communication in India is undoubtedly required and will continue manifold. Finally, I'd like to conclude and thank Mr. Bhatia and all my colleagues who have joined from far-flung area with my remarks saying that India has a huge potential for satellite communication in India's digital future with the right and enabling initiatives and the policies in place and availability of the adequate spectrum by striking a balance with terrestrial communication need, India can certainly meet the communication requirement. I thank you very much for all of you, and we look forward to building on today's dialogue, exchanging ideas, and constructive engagement of all stakeholders on how we can work together to achieve our objective and bridge the digital divide for connecting the unconnected. Thank you. Namaskar. Jai Hind. Thank you very much.
Thank you, Devaji. That was really very, very encompassing and brought the whole field here. And now I'll turn it over to our satellite guru, as you rightly said, UK Srivastaji, for his address, chief guest address. UK, over to you.
Well, thank you very much, Bhatia sir. Good evening, good morning, good afternoon, as the case may be. Uh, Good evening to my fellow panelists here from India and abroad. And finally, I was able to see the face of Mr. Goel. He had switched on his video. And good evening to all the participants of this webinar. Mr. Dua was talking about National Digital Communication Policy 2018. This document really addresses many of the issues that the satellite industry is facing today. A lot of work to simplify the processes and procedure is underway. And these processes will also be aligned with the new SATCOM policy. He was mentioning about the very important issues that the NDCP 2018 addresses, and now it's at the implementation phase. One of them was that a review of the regulatory regime for satellite communication. And as you know, the new satellite policy has come, and DOT is also aligning its policies, trying to introduce single window concept for issuing licenses, etc. The other issue was satellite communication technologies in India. This will certainly happen with the possible entry of foreign players thanks to the new SATCOM policy that is being introduced. And thirdly, the developing an ecosystem for satellite communication. This is what is happening. This is what we are debating here today. So all these issues which were highlighted in the and made part of the policy for 2018, the goals are being realized. So it's a very happy occasion for all of us. And the recent revision of SATCOM policy is aimed at bringing a more certain regulatory environment and a transparent process for the issuance of authorizations. All the stakeholders have given their inputs on the draft policy, which was placed on ISRO's website, Department of Space website, and I'm sure that this will lay emphasis on not only expanding the existing satellite communications market in India, but also on the self-reliance as far as India is concerned. There was a reference to the interface requirement document of TEC, which Mr. Dua was alluding to. So I must inform this gathering that TEC has concluded, it has actually conducted several workshops on this issue involving the industry and all the stakeholders. And we have kind of removed all the restrictions that were there earlier in the interface requirement document. And it has been, very much appreciated by the industry. I have spoken to many representatives of the industry, and they are very happy with the document which we are going to bring out. It will take some time because we have to finally take the opinion of ISRO and release this document. So I'm sure this whole process will be completed in a very short span of time. All of you know that the WRC 19 had very favorable outcomes for the non-GSO satellites, the topic of today's discussion. And a very stable regulatory framework was defined for non-geostationary satellite orbit systems based on a milestone process enabling mega constellations to rapidly come to fruition. Now, this will ensure that more affordable means of connectivity can be offered to citizens of all countries. The ITU member states agreed to adopt an innovative new milestone-based approach for the deployment of NGSO systems in specific radio frequency bands and services. The agreement reached establishes regulatory procedures for the deployment of NGSOs, including mega constellations in low Earth orbit. Under the newly adopted regulatory regime, these systems will have to deploy 10% of their constellation within 2 years after the end of the current regulatory period for bringing into use, 50% within 5 years, and complete the deployment within 7 years. So this is a very great agreement that has been reached, and the milestone-based approach will provide a regulatory mechanism to help ensure that the master interface international frequency register reasonably reflects the actual deployment of such NGSOs, satellite systems, specific radio frequency bands, and services. Indeed, the availability of launch vehicles capable of supporting multiple satellite launches, mega constellations consisting of hundreds of thousands of spacecraft, are becoming a popular solution for global telecommunications. You must remember that India is also a very prominent player as far as the launch of satellites is concerned. So this includes extensive low latency broadband coverage, remote sensing, space and upper atmosphere reach, meteorology, astronomy, technology demonstration, and education. And today, two of the non-GSO satellite proponents are speaking in this workshop. I'm very happy that they are participating in this. That is, Bharti Enterprises-led low Earth orbit broadband satellite communications company, that is OneWeb, will soon start launching an initial set of 360 satellites to construct a global satellite constellation that will provide enhanced broadband and other services to countries around the world. And secondly, Telesat is launching Telesat Leo. That's a revolutionary satellite constellation of highly advanced satellites in LEO to deliver fiber quality throughput in large capacity in terms of gigabits of bandwidth and also low latency anywhere on Earth, as well as provide a future-proof solution for backhaul cellular 5G traffic. Telesat will also provide high-speed broadband access to rural and remote communities, planes, ships, enterprises, and government users. It's a very good news as far as these two players showing interest in the Indian market. There are many other constellations that are having number of satellites already launched. For example, e-commerce company, that is Amazon, they are to deploy in excess of 3,000 satellites. And then the Elon Musk controlled company Starlink will have more than 40,000 satellites. So these are all very exciting times, and I do recognize that both GEO, STS, and NGSOs are going to play a very important role in the rollout of 4G and 5G services in the country. The government is also ensuring pilots and tests that are being conducted in this area. I'm told that WPC is examining several proposals for issuance of test or demo licenses. And in line with the theme of Atmanirbhar Bharat Abhiyan, a lot of startups and MSMEs are being encouraged in the country in the satellite broadband sector also. There is another information that I would like to share with you is that TRA had come out with a consultation paper on providing minimum speed of 50 Mbps to the customers. I'm sure that satellite industry would have also given their inputs and comments on this paper so that TRA can come out with a very good and favorable policy to the SATCOM industry. And the government has determined, it is determined to the ease of doing business and providing a predictable regulatory climate. So overall, these are very exciting times for the industry. The industry should take best advantage of the environment and provide country much needed support in broadband penetration, as well as the effort of government regarding Atmanirbhar Bharat. So with this, I end my talk. I thank ITU-APT Foundation for inviting me to this event. Looking for the event and wish that it is a very successful event. Thank you very much.
Thank you, UK Srivastava. That was a wonderful summary of what is going on in India. I think, as you rightly brought out, there is a new space policy and there is a new SETCOM policy, and a number of comments have been given, including by the ITU-APT Foundation of India, and hopefully this new policy will take shape soon. I'm also very happy that you mentioned about the test and trial licenses that WPC is issuing, which is very, very important for carrying out initial market assessment. Uh, One other good thing that you mentioned about was the outcome of the WRC 19, which was very, very important for the NGSOs. And as I mentioned, we are so lucky to have Dr. Badawi in the audience here, who was chairman of the WRC 19. And if after this first presentation, maybe I will request Dr. Badawi to say two words to our gathering. So I'll invite him at the stage after this first presentation. So thank you again, Mr. Yukesh Vasta. Very, very useful interaction. And hopefully we will have this interaction continuing. I would now go on stage to the team from OneWeb, from Mr. Tony Azreli as the first speaker, followed by Mr. Chris McLaughlin. So, Tony, it's over to you with your initial presentation. And after that, before going to Teleset, I will request Dr. Badawi to say a few words. Over to you, Tony.
Bharat, can you hear me?
Yes, I can hear you very well.
Excellent, thank you. Can you see my presentation as well?
Yes.
Thank you. Okay, thank you for this opportunity, Bharat, and also I wanted to say thank you to the participants as well as to the high-level emissaries from ITU-APT as well as the Indian government for giving also this opportunity to present today. I was asked by Bharat to give you a short tutorial on non-GSO satellite systems in general. So I won't be talking sharp on behalf of OneWeb, but I will have Chris after me who will provide additional details on the OneWeb situation in the system and coming out of Chapter 11 as well. So I will let me know if I'm running out of time, Bharat. There's about 30 slides. I'll be as quickly as possible, which will provide an overview of non-GSO systems in general and also the new constellations that we are seeing to be deploying for the provision of broadband across the world, basically. So I'll talk about legacy systems plus the mega constellations. Some ITU matters related to non-GSO systems has already been alluded and also proposed by the previous speakers. A few words on clean space and management of debris and some conclusions, basically. So first of all, as part of my tutorial, basically, is to explain what non-GSO systems are and satellites. Basically, any satellite which is man-made can be launched into space. In fact, the very first satellites launched into space, like Sputnik and others, they were not geostationary. They were actually non-geostationary. They were meaning that they were circulating the Earth with a period which is basically less than 24 hours in a way, which means that they will actually cross the sky as we will look at them. They will just cross the sky within minutes and then will disappear. So this figure shows you pretty much that with physics and Kepler's laws, a satellite will basically be circulating an orbit, and there could be circular orbit or elliptical orbit or even hyperbolic orbit, depending on the mission. In the case of the communication satellites and some of the scientific missions, it's worth having them in circular orbits because that will provide a global coverage in a way, or coverage that the satellite can see the Earth the same way everywhere it circulates the Earth. The orbit could be inclined, as well as could be the equatorial plane as well. When it's inclined, it could also be polar. In fact, many of the constellations and satellites usually use the polar orbits because they provide visibility of the Earth, let's say, throughout the day and throughout the year and the months, everywhere on the Earth. And by polar orbit, we mean some kind of inclination of about 87 to 89 degrees. Usually we don't use 90 degrees because it becomes almost useless to have it at 90 degrees, and it's better to have it slightly lower than 90 degrees in terms of the orbital inclination, basically. There are many constellations which actually satellites are using inclined orbits. Around 52, 55 is the norm, basically. There could be a 60, there could be even a 30 or 40, depending, again, on the business plan and the mission. The orbit and the orbital planes, there could be many numbers, basically, of orbital planes, so that the Earth can be covered simultaneously by many satellites. That will depend on the business plan and the mission of the satellite system and constellation. So just to differentiate between different types of orbits, there is a low Earth orbits, as you see here on the left. These are orbits which usually are below 2,000 kilometer in height above the sea, above the Earth's surface. Usually they will have about 1.5 to 2 hours per orbit, so satellites will circulate the Earth within that time frame. Then we'll move to medium Earth orbits, which are orbits between above 2,000 kilometer, let's say between 5,000 and maybe 25,000 kilometer. These usually will have an orbital period of about 6 to 12 hours. And there are many applications even in MEO. There's communications applications like O3b, but there are also navigations, positioning like GPS and others, which are about 24,000 kilometer. They're quite high in a way. And then, of course, you have here high elliptical orbits, which can have an apogee and a perigee, which can go between maybe a few thousand kilometers to maybe even 50,000 kilometers in terms of the distance from the Earth. They're usually more than 12 hours orbits. And of course, so we know quite well the GEO orbit at around 36,000 kilometers, which is a 24-hour orbit, which will see the satellite in the sky basically fixed as the Earth rotates, basically. The number of satellites in each of these orbits will vary. Of course, the higher you are, the lower number of satellites you require to serve the Earth. And the lower you are, you require many numbers of satellites to connect and to cover the Earth. That's why LEO constellations and LEO satellites constellation have a huge number of satellites, while in MEO you're looking at tens, 20 satellites at maximum, basically. And of course, even the size of satellites will vary depending on the orbit as well. Again, depends on the mission. I will show you in a minute. In fact, on this slide, you'll see that on the left column, the different denomination of satellites between pico satellites, nano CubeSats, for example, small satellites. Then you have small, we can say small GEO, HEO, MEO satellites, or large GEO, HEO, MEO satellites. And there are different sizes. As you can see, the large satellites can be as big as a bus, and the smaller satellites could be as small as your fingers, basically. I've seen satellites as like 1 centimeter size with a very small antenna. These are sort of the pico micro satellites that some companies are building for particular reasons, particular purposes. In terms of orbital heights, you'll see that the very, very small satellites, the orbits are maybe up to about 400, 500 kilometer, and for various reasons. One is because the power they have is very small, so you want to make sure the link is robust with communication and data communication from the satellites, as well as the fact that below 600 kilometer, you are certain that the satellite, without any external propulsion, it can fall back to Earth within a given number of years. I think if I'm right, 750 kilometers is the limit by which the satellite will fall back to Earth within 25 years, which is the IADC, the Interagency Debris Committee, which has a guideline of 25 years, basically. The size, as I said, the mass, you can see the mass of the satellites is quite varying. The power levels will vary depending on the size. And of course, the other features are that the smaller satellites will not have their own dedicated launch, so they will be piggyback on particular launchers, while the bigger satellites, the more heavier satellites, because they have a big business plan, will require dedicated launch because they have to fit in a particular orbit and a particular inclination. So that's quite important as well. So before 2008, in fact, as I said, non-GSO satellites were here already from the very beginning, before any geostationary satellites was put into place, and of course, before 2008, there were not many small satellites. Of course, we had the big LEOs of the 1990s. For those that remember Iridium, Globostar, even ICOP from Inmarsat, for example. And here you can see on the chart the different orbits they occupied, as well as a number of satellites on that orbit, and a number of planes is different. The sort of orbital height, like Iridium is around 700 kilometer, Globostar, which the both Iridium and Globostar operating today, Globostar about 1400, ICO was at 10,000 kilometer. There is still one single satellite in orbit at that height. And the different frequency band you see here on the right as well, the frequency band utilized by these voice and slow data communication systems. These are where the GMPCS type communications, which many of you might remember. At that time in the 90s, we also had Teledesic, which was a precursor to OneWeb, in fact, and Teledesic and others, basically, which wanted to launch and wanted to provide internet access with about 888 satellites at around 500 kilometer height. Each satellite was going to weigh 120 kilograms and was going to operate in Ka band, basically. That's the precursor. Goes back to 1995, WRC 95, in fact, when it came to look for frequencies. Also, there are many IoT machine-to-machine systems. Well, there's not many actually before 2008, but we had Orbcomm. Back in the 90s, Orbcomm was and is still actually operating today, a LEO constellation of about 25 satellites, maybe increasing to about 50 now, at about 600 kilometers, providing IoT machine-to-machine, very low data communications in VHF band, basically around 137, 400 megahertz bands. After 2008, a spur of activities came, and I have to say it started off with O3b, with the idea from the founder, both of O3b and OneWeb, Greg Weiler, who came up with the idea of the MEO constellation, MEO equatorial constellation. So you have this MEO constellation at the equator, around 8,500 kilometers, with about 12 satellites. Operating in Ka band. Satellites were big, are big, around 900 kilometer, 900 kilograms basically. And then after that, in about 2012, OneWeb Filings and Company was sort of formed, initially in stealth mode, in fact, with some ITU filings through the UK, with about 720 satellites in the filing, but operationally 648. Idea was to launch 150 kilogram satellites in KU and KA, and follow that, many other satellites came, many other constellations came after that, Telesat, SpaceX, LeoSat, for example, Kepler, Kuiper with Amazon, for example. So you'll see here the evolution of the spur of mega constellations starting from 2008 onwards. The LEOs are the ones starting here from 2012 onwards, basically. And you'll see the differences in orbital heights and sizes of the satellites themselves. Let's not forget that it's not just the broadband communication satellites that are useful to humanity. There's also the very small satellites, the nano-pico satellites, CubeSats, which provide connectivity for the Internet of Things, machine-to-machine communication, and very, very slow data communications that are required by sensors, which could be deployed anywhere in the world, farming and buildings monitoring, for example, and so on. So we start off with Orbcomm, which is still operating today in VHF, UHF bands. Then we have very modern and new constellations which have come into being over the last couple of years. We have Hyber in the Netherlands, Mariota and Fleets in Australia, CNES in France, and there are others actually. So I'm not going to be able to. I wasn't able to put it on the single chart, but there are also many others. You'll see that the sort of range of orbital heights is around 600 kilometers. Again, this is making sure the satellite can be brought back to Earth naturally over a period of time after the end of life. And the other most important thing is that the bands they utilize is the MSS allocation in UHF, and WRC 2023 is looking at a new agenda item 1. I think it's 1.7 or 1.8 or 1.18, sorry, which is looking for additional frequency bands that these systems may require in the future. In terms of applications, you'll see that mega constellations are aimed at providing broadband internet, eSIMs type applications for aeronautical and ships, connected cars and vehicles, backhauling for 4G, 5G, IoT and machine to machine, potentially positioning, navigation, and timing. And because they do have in the infrastructure some advantages, which I'll talk about a bit later in another slide. And of course, the CubeSat nanosat technology applications, as I said earlier, a lot of it is actually scientific missions, some kind of navigation provision as well, IoT machine to machine, short message voice, and so on. So this is a whole list of applications, and you can have much more innovative applications which the community, scientific and also university community, government community can also think of. Benefits of non-GSO constellations. Again, this is a slide I showed at your last meeting in October about whereby we discussed about benefits of constellations for India. So you'll see that non-GSO constellation, depending on the orbital height and also depending on the inclination of the plane, inclination of the orbits, can provide truly global coverage around the globe from pole to pole, in fact. It works also in obstructed terrain. So basically, even behind the mountain where you can't see the GSO orbit, you can always have a satellite visible at high elevation when it actually comes from a LEO constellation, for example. And low latencies, depending on the orbital height, you can go down to 10 milliseconds to even to maybe 100, 150 for the MEO constellations, for example. So that actually is very compatible with 5G technologies, for example. High broadband speed. These systems can provide quite a high broadband speeds per terminal. Mobility is seamless and ubiquitous. Mobility can be provided by the systems. That's why they've been built in a way that they can actually be mobile. And also, the terminals of satellites is smaller than the existing VSATs, for example, because the satellites are much lower in orbit and will require lower power and a much better robust link that will actually make it possible to deploy extremely small satellites, basically, small dishes, basically. And of course, the aim of these systems is to lower the cost for the end users. So I'm going to tackle the national licensing for these systems. First of all, generally, I was a regulator myself. I was for 5 years head of the space and science division of Ofcom in the UK. I was doing all the licensing for UK-based systems and operators, plus representation at the ITU and internationally at CPT as well. Generally, licensing is for spectrum management purposes, basically, although there is a market element into it. But still, for satellite, we regulators tend to regulate these systems on a spectrum management purpose, basically, which means that from a regulatory perspective, a lot of the regulations which are in place for GSO systems should be easily transportable into non-GSO systems. In fact, at the end of the day, what the regulator is worried about is the interference coming from the terminal. If the terminal is actually fixed or the fixed pointing, or if the terminal is actually tracking the satellites, it won't change a lot if you actually look at the details of the interference environment. Sometimes if there are no other use of the band, there is no interference environment, and basically there is no spectrum management per se, in a way. Also, the issue is that between GSO and non-GSO is that the number of terminals of non-GSO systems could actually be quite large. In fact, the markets and the scope of business for non-GSO is to provide tens of thousands, hundreds of thousands of terminals per country. And if you get a country like India, which is quite large, for which you're going to have most likely tens of satellites over the country. You are looking at maybe 1 million terminals over the countries within a few years. So that requires some innovative ways to license these terminals, and often I have seen and I have procured licenses on a blanket basis, light touch licensing like in the UK, at a very almost no cost basically for the operator, or exemption from licensing if the terminal comply with particular type approval requirements, interface requirements, basically, that lower the interference potential if there is interference. Then you can exempt the actual individual terminal per se, and that provides a very good regulatory framework for these non-GSO constellations. And of course, the last bit is that licensing fees, if you want to make it low cost for the end users, especially in countries like India or even Africa, for example, or Asia in general, you need to lower the cost as much as possible, including the license fees. So a lot of the costs I've seen, the fees I've seen, are based on a cost recovery process. I have to also, I was very pleased actually that Mr. Dua and also Mr. Srivastava earlier gave very positive statements for the review of regulatory framework in India. And this is very welcome for our community, because by modifying your regulatory interface requirements, as it is the same, similarly in Europe we have interface requirements, it is possible to actually exempt from licensing the terminals as well as from spectrum utilization. Usually in Europe there is also user spectrum exemption for the operators if there is no interference, or very, very extremely low interference involved. Oh, sorry, I went back to the presentation mode. Okay, so licensing. So what kind of licensing we need? We have the space segment, we have the ground segment, and the user segment. So you'll see that there are different radio links from the satellite to the Earth stations in the ground segment. And then you have TT&C feeder links, of course, and then you have a service link to the user terminals. So those are the type of radio frequency licensing that I'm worried about in the market access, basically. But there are different other licenses as well. There is ITU satellite filings which are required. There is a space system registration and authorization required for very small in very small number of countries for covering that country. Often it's called landing rights, but it's not a term which is used harmonized globally. But there's only a handful of countries which require this kind of authorization. And of course, there is a launch and operations license, which is a license provided by the country where the satellites and launch are procured from. And that's to comply with the Aerospace Treaty. 1967 Aerospace Treaty, basically requirements of registration and authorization from national countries, basically. For the ground segment, I said quite a lot. Earth station feeder links and TT&C gateways require some kind of a national licensing through coordination with existing users, as well as user terminals. As I said earlier, blanket license and type approval should make it actually easy to license this kind of equipment. So one-stop shop is a very good approach that I've seen. We need flexible and clear regulations, quick and fast. Within a couple of months, some operators will require some licensing of their operations in the country. The regulations is actually also welcome if possible. Recognition of foreign equipment standards is actually useful, because we don't have to type approve equipment in every single country of the world when it's already been type approved with particular high quality standards, for example, like ETSI. And a reduction in barrier to entry is actually also important for the importation of the equipment. So that requires some care. Very quickly on spectrum matters, IoT and machine-to-machine satellites like Orbcom, Fleet, Hyber are using MSS allocation in UHF bands around 400 megahertz. So I hope you have seen this most likely in your country as well. WRC 2023 will look at additional frequency bands under Agenda M118. The S-band and X-band also are utilized for feeder links of these systems. They provide very low data communication, sometimes even some voice. GMPCS do provide voice, like Iridium and Globostar. They're using MSS allocation in L-band and S-band. The
25 hertz?
Okay, and then broadband constellation are utilizing Ku and Ka bands frequencies in the future. In fact, WRC 19 has given access to Q and V band around 39 to 49 gigahertz for the future systems. Sharing with IoT and machine-to-machine system. Well, this is for those that understand the ITU radio regulation. That's the footnote which provides the use of these bands for non-GSO satellite systems. The satellite antennas and the terminal antennas are actually low-gain omnidirectional antennas, so actually sharing is quite difficult. However, coordination between the systems can show that sharing is possible. There are many mitigation mechanisms like low power as well as low duty cycle. So once every 30 minutes, once every 5 minutes, the communication is sent through a packet data. So in effect, the systems can actually coexist in the same frequencies if it's looked at in more details. L-band, S-band constellations are actually difficult to share because of the low-gain antenna, omnidirectional antennas, and the fact that they operate continuously through voice and other means. So that's why you see in the L-band, Iridium, Globostar, and others, they have to band segment because they can't share their frequencies. KU band and Ka band constellations. I have provided here some charts on how you share with GSO systems and how you share between themselves. With the GSO systems, it's very simple. I'm not going to read the slide, but there is Article 22 EPFD limits, which actually provide a means to operate at the same time with the GSO systems. And this is based on avoiding the pointing to the GSO arc by the non-GSO systems. And that provides there's a tool at the ITU, resolution 75 and resolution 85, plus there is a software tool which actually verifies that your filing can share with the GSO system by applying EPFD limits. The same thing happens with the Ka band for non-GSO. However, some frequency band in Ka band are not shared through EPFD limits. They have to actually, they're shared through Article 9, 9.12, in fact, coordination. That's why I put this slide here on the frequencies, because there's different slots in Ka band which are shared in different ways. Non-GSO, non-GSO sharing. We note that Article 9 has all the necessary tools for coordination and sharing between non-GSO systems. My view and the view of the ITU is that it's possible to do coordination between satellite systems because, in fact, the user terminals are actually directional, and because they are directional, it's possible to find ways to share the frequency bands. This was mentioned before. The ITU WRC 19 has given the milestone approach for non-GSO systems. That's a very excellent thing that the ITU WRC 19 did. And the reason this was done is because we don't want to have one single system basically blocking other satellite systems if they don't launch anything. So the milestone approach is about making sure that if you are serious in the game, you need to launch your satellites within the milestones that you have there, 2 years, 5 years, and 7 years. Otherwise, you lose your priority for a given number of satellites. Last part, which is very, very quick, space debris is a very important issue for everyone, not just the satellite operators, but also the general community that wants to launch into space. Unfortunately, today, we don't have radars that can track and check if there are debris lower than 10 centimeters. So this chart is showing you the number of debris more than 10 centimeters in size over the number of years from 1957 onwards. There's about 20,000 debris in orbit. A lot of it, you see the different types of debris between the fragmentation debris, spacecraft, mission-related debris, and rocket bodies. There's still quite a large number of bodies, actually, rocket bodies in orbit from the early days. Of course, the unknown debris population can be estimated at about 750,000 small objects, uncatalogued, basically. And by 2019, 2020, there should be new sensors which should be able to check debris up to about 1 centimeter in size. So the population of these small objects is quite huge. And even that 1 centimeter paint flake can cause damage to ISS window, the International Space Station, can actually have damages on their sort of windows, basically, or their hull, basically, by a flake because of the high velocity, high momentum that this debris can have. Just a last slide here. Many companies are actually coming up with solutions to try to reduce debris. This could be maneuvering to avoid collisions, so you have to have a mechanism to maneuver your satellites to avoid collisions. Returning satellites and rocket bars back to Earth, that should be an active way of actually removing dead bodies, or actual rocks, basically, in space. Increasing reliability of the space objects, so the actual components of, like for example, the maneuvering small rockets on the spacecraft should be actually have a high reliability. And launch your missions which are higher risk with debris lower than 500 kilometers, because that will actually naturally fall back to Earth. Anything above 750 kilometers will take hundreds of years, if not thousands of years, to fall back. And in fact, in GSO, they don't fall back; they remain around 200 kilometers above the GSO orbit. I have concluded my presentation. I hope giving you an overview of the situation for non-GSO constellations and also small satellites. Any questions I'll take here and afterwards if you want. So thank you very much.
Thank you, Tony. That was very, very comprehensive, and that was provided a great overview. So thanks for doing it. And it is good as always to listen to you.
My
Thank you.
pleasure.
Since the time is short, I'm going to go straight over to Chris and to talk about the status of OneWeb. And I'm going to share his presentation here. Let me see if I can do that.
Just while Bharat is doing that, which I very much appreciate, thank you everyone for inviting us here, and thank you, Tony, for what I can only describe as one of your usual tour de force in terms of your knowledge base and information. It's always amazing to hear the degree of detail that can be put in place. I should really describe OneWeb as coming back from a near-death experience, and it's done so like a phoenix from the fire, with the great support of Sunil Bharti Mittal, who is an extraordinary man. And I was delighted that a small miracle happened, and he met up with another extraordinary man, the Prime Minister of Great Britain, Boris Johnson, who, between the pair of them, decided that we absolutely totally must save OneWeb so that it becomes a global platform for multiple countries to work with. The intention throughout was, and the descriptor that we had was, imagine OneWeb as a table and chairs. Imagine, Prime Minister, that you own the table and the chairs. Think of who you can invite to the table. And the first person that also took up the chair was obviously Sunil. And the intention then was to see if we could build a new OneWeb. So I wonder if I might ask Bharat to put up the first slide. I can't see any. If you can already, that would be enormously kind.
Oh, I thought I was already sharing. Wait a minute. Again, let me try it again.
If not, I'm happy to just talk if that's more convenient.
1 second. Share.
You can see why I've so cleverly asked him to do it, because I was terrified of not making the thing work properly.
Can you see it now?
Oh, it's absolutely perfect. Thank you. So as I've said, the aim is once again to be building a truly global communications network, one that can reach the billion or so. And I have to say that our executive chairman, Sunil, is extremely excited by the idea of being able to connect up the unconnected in India, and really excited with working with ISRO and working with the Department of Telecoms to try to bring this into a reality. If I may have the next slide, please. So may I have the next slide?
Yes, I'm trying. Wait.
Sorry, do forgive me. If it won't play, that's fine. I'll just carry on. So if I thank you very much. So if I explain the setup now, it is HMG, UK government, and Bharti Global, and each of them own approximately 42 to 42.5%. SoftBank retains a small holding, and there are other small shareholders in there at the moment. The company has publicly raised 1 billion in new equity from those two partners, and it has a very clear path to being very fully funded very quickly. There are a number of sovereigns, a number of financial organizations who all wish to participate, and I can be very clear that all of that money will be forthcoming, and that you have not to worry that there is going to be a repeat performance of what sadly everyone experienced back in March. The launch plan has restarted, and again, I need to flag the vision of Bharti Global, who, whilst we were still discussing the acquisition of the company, were able to say, well, what would it cost to build the next 36 satellites? And the figure was given to them, and they said, well, just do it. And it was an incredible gesture by them, but they committed to making the satellites before they formally owned the company, with the result that I'm delighted to say we intend to launch our next 36 satellites from Vostochny in Russia, Siberia, on the 17th of December. So India and the UK will be back in the satellite business as of the 17th of December, and the intention is to then look for approximately a monthly launch. We have to be aware of the holiday season back in the USSR, in the CIS, and indeed elsewhere around the end of the year, beginning of January. You can see recent expressions of interest with a focus on the new ownership with the UK and Bharti, with the Prime Minister and with Sunil Bharti Mittal leading, with a real emphasis on strengthening security ties. There was an interest between the Indian military, the Americans, the UK, and other Five Eyes parties, given all the global challenges that we now have, to try to bring together operation of the OneWeb system for the further benefit and the national security and resilience of India, amongst other countries and participants. We have a very simple message, which is that we're trying to take forward, which is reliable, resilient connectivity. There's a disruptive element in alternates, as we heard earlier. It's hard to get all that fiber laid into all those places. It's hard in the UK, so goodness knows how much more demanding it would be in India and elsewhere. So there will always be a place for fiber, obviously, but equally there's a place where fiber can't reach the satellite to provide that connectivity. And we will be asking the regulatory team to look carefully at what we're all trying to do with satellite. In the past, perhaps it wasn't fully planned in, but as Tony says, if the regulatory regime is supportive, then satellite can be supportive of the national objectives. And we see a very strong mix between the 5G networks and the backhaul and the extension of those with the satellite operations. As I've said, the internet access everywhere for everyone all the time. For us all to be connected has to be the way forward. If I may go to the next slide. Oh, we have. Okay. So the launch timeline, as I say, has restarted. And we are manufacturing satellites at the rate of 2 a day. Those are being done in the Florida factory. Historically, there was a joint venture with Airbus and OneWeb to build those satellites, and that production line has continued. There is an intention to move the production line by Gen 2 to the United Kingdom and to develop further payloads, but all of that is evolutionary at the moment. All the focus is on getting Gen 1 up by the end of 2022, with the first milestone being the latitude 50 degrees from north being the goal to cover, if you like, the northern polar region down to approximately the north of the Mediterranean. The launch cadence is obviously well planned. We've already committed to 16 further Ariane launches, and we will be rolling those out on a regular basis throughout 2021 and 2022. I should say that we have also enthusiastically spoken with ISRO, and we hope that there may be some opportunity to use the Indian space program to launch satellites later on in the program as the opportunity presents. You'll see that there's an extensive testing through to 2023, but you should reckon that the globe as a whole will be covered by the end of 2022. On proving the concept, well, there are 74 satellites already up there, and the demo speeds have showed 40 millisecond latency, speeds of 400 megabits per second, and those demos have been taking place in Alaska. If you look at disrupting satellite communications, Tony has spoken at great length about the difference between the different bands, and I'll bow to his knowledge on that area. Just simply say that at 1,200 kilometers, we have the best look angle, and we also have the ITU priority on satellite spectrum, and we feel that we're in a good place to deliver India's needs and concerns and to support those requirements. If I may go to the next slide. Gateways are in full build. A number of the gateways are already fully committed. We've looked at gateways for India, and we're in active conversation with India as well on that front. We fully intend to be part of the telecoms planning and communications fabric for India and for other major nations as we all move forward together. May we go to the next slide? So it's a land, sea and air network. It depends on the antennas and as they come available. We will start with dual parabolics, which will track the satellites. I'm sure you're all aware that effectively the first gain of a LEO is that your terminal looks straight up into the sky, so it's less likely to be put off by a mountain range or a tall urban area without being able to make connections. And if you can imagine a Venetian blind style structure, you're effectively getting a handover from satellite to satellite. So you either need two parabolics that track one across the sky while the second acquires the satellite as it comes over the horizon, or you need a phased array antenna, which are in development, which will be electronic solutions. And indeed, India is looking at some of those terminal solutions as well. I would say that we will engage across all those markets, and you can see that there are a number of different terminals in development, as I mentioned at the moment. We're looking at speed, ease of installation, looking at high performance, and we're looking to innovate. And one of the key things we're looking to do is work on price, which again is why the Indian manufacturing base is so attractive to what we're trying to do. We've taken a lot of your time, so I'm just going to say a very simple thank you. I wanted to introduce OneWeb. We're back, we're determined, we're well financed, we're very excited to be with our new partners and to be with a space country that's actually ahead of the United Kingdom in the way that it goes, in that we gave up our rockets many, many decades ago, whereas India has managed to persist. And so we're looking forward to learning a lot from you. So thank you for your time and for the kind invitation. And I will step back and let the geniuses and experts continue.
Thank you very much, Chris. Wonderfully done. And I think you really encapsulate within a short period of time the exact status of where OneWeb is right now and where it is going. I think great. And thank you very much for being part of this. So,
you're very kind. Thank you all.
Thank you very much. I'm going to move straight over to the next set of presentations from Laura and Manik. I think Manik is going to take off. So over to you, Laura and Manik, for the teleset part of it.
Yeah, thank you, Bharat. And as Mr. Srivastava said, good morning, good evening, good afternoon, depending on which time zone you are. I'm going to try sharing my presentation. Bharat, if you could confirm, you can see the presentation. Laura, can you see the presentation?
Yes, it is there.
Yes.
Go ahead.
Oh, okay, thank you. So I believe all the speakers so far have done an excellent job of introducing LEO and making the case for how LEO could be another solution, another toolkit in the problem of solving universal connectivity and that's what we believe our mission, common mission is. It's about not just about digital divide. It's not just about connecting people, but it's about connecting people and communities with the best internet or city quality internet that rural and remote areas do not have. And of course, it all has to be done affordably. Otherwise, we are not solving the problem in the right way. So my ambition today as the head of product at Telesat, for Telesat LEO, I'll take about 10 minutes to talk you through how Telesat specifically is trying to solve this problem. Because as Tony mentioned from OneWeb, it depends on the mission you're trying to solve, and not every LEO is same. So we've taken an approach, and I'd like to show you about that. And I'll hand over to Laura to talk through the spectrum and regulatory matters. So the first question that comes up is why LEO, and why are we all talking about LEO right now? As Tony mentioned in his presentation, over the last 6-7 years, there's been an increased interest and activity in the mega constellation space for broadband. The reason is quite simple. The gap of connectivity was always there in connecting people or communities or ships or planes, but the technology and the economics were not yet there to make it all come together and work. We believe that with a lot of the development that's happened in the mobile sector, especially whether it is better signal processing, miniaturized electronics, advances in artificial intelligence and machine learning, but also launch costs have tremendously gone down, including players like ISRO as well, and private players globally have helped reduce the launch cost exponentially over the last 3 decades. So all these factors have come at the right time, which make LEO not just technically possible today, but also viable from an economic and business case perspective. And all these cost economics obviously help in getting the price point to the end user much lower and more affordable. So we believe we are at a very exciting point in the overall space industry perspective, where multiple trends have come together, and LEO mega constellations for broadband will offer another complement and another toolkit in the connectivity landscape, complementing terrestrial technologies like fiber and microwave, as well as the traditional geo satellites to offer the best solution required for a particular community. How has Telesat gone about it? For those of you who don't know, Telesat is not a startup. Telesat is almost as old as ISRO. We've been in business, in operation for more than 60 years now. For us and for other players in the market combined, we've been involved in launching over 100 geo satellites to date. Today, we operate 16 geo satellites across all bands, C, K, U, K, A, across the globe. So we've been observing the satellite space for ourselves and advising others about how to launch satellites for quite some time now. But about 6 years ago, when we started working on what is the next 50 years of the satellite industry, and as well as for Telesat, we came to the conclusion that with all the technology and the economics being right there, LEO is the only viable solution for broadband, SATCOM broadband of the future. And specifically, we've decided to focus on serving the enterprise application or the commercial application space with a LEO constellation. That's the mission for which we've designed the LEO network. What do I mean by enterprise or commercial application? We are focused primarily on better backhaul for mobile operators and for communities, and also backhaul for mobile assets, whether it is ships or planes or vehicles on land. And we focused on that particular mission because we believe a hybrid network is the best approach to get affordable internet everywhere. Hybrid network being a very solid, reliable, and economical backhaul coupled with a local access network, whether it is the mobile RAN network or any other local network run and operated by a local service provider or a local telco. So that's the mission around which we've designed our entire LEO network. What does the Telesat LEO constellation include? It includes about 300 satellites in a mix of the polar and inclined orbits, which have been introduced earlier. And we went with this hybrid design so that we can maximize both coverage and capacity. Whereas the polar orbits give us full global coverage, most of humanity doesn't live in the poles. It lives in mid latitudes. So our inclined constellation is our capacity layer, where we are going to populate about 2/3 of our satellites. So with that, we are maximizing, as I said, coverage and capacity at about 1,000 kilometers. But it's very important for everyone to also remember that not every LEO is same, and the satellites that we've designed to put in our constellation, we believe are some of the most state-of-the-art LEO satellites that any LEO operator intends to put. These are reasonably large satellites, 800 kilogram, about 3 kilowatt satellites at about 1,000 kilometers. And we've used every required technology that we need to we make sure that it meets the enterprise needs, whether it is all the satellites interconnected with inter-satellite links, whether it is onboard processing for the satellites, so that basically you're talking to a switch in space. It's no longer a bent pipe or a mirror in space. And highly sophisticated beam technology, so you don't have any more static beams. The beams are highly flexible, they can hop, and anyone who's much closer to an advanced 4G or a 5G radio will relate very closely to how our satellites are. It's almost a similar technology. But we're not just building a satellite constellation. The satellites will be complemented with an overall terrestrial network with what we call landing stations. Similar to a cable landing station, we would have our own satellite landing stations distributed globally. And of course, we intend to build these in India as well. And this is where we will interconnect with our customers. And all this is going to be orchestrated with what we call the Constellation Network Operating System. So just like your operating system in your computer makes sure that everything is working well, our CNOS is going to make sure that the customer stays connected to the right satellite, and the satellites are connected to the right ground infrastructure, and overall the end-to-end link is working to the right SLAs. So that is a custom, highly sophisticated piece of software that Telesat is building to operate this entire network. What will the end customer have or experience? As I mentioned, for a telco or an ISP, of course, it's going to be high throughput, and we can deliver throughputs as high as multiple gigabits, up to 7 gigabits to a single site. But this is not only a high throughput constellation. We will serve throughput needs from as low as 1 megabit to a site, all the way up to multiple, say, 7.5 gigabits to a site, and everything in between. Low latency is a natural physics benefit, but also the overall system processing delay is quite low. So we will deliver terrestrial like latency. The third aspect on flexible capacity, this is something I want to emphasize here. Not only because, so what do I mean by flexible capacity? As the picture on the right is showing you, as I mentioned, the beams that Telesat LEO's satellites will put down, it's not static. It is not a fixed beam architecture. It is the beams are highly flexible, steerable, and will be only put down in areas where there is demand. So why is this important as a user? This becomes very important because the constellation, the supply of capacity will be perfectly aligned with the demand that it is seeing. And there will be no capacity wasted where there is no demand. For example, across in the oceans, if there's not much demand, then those beams will be steered to the extent possible closer to land areas where there is demand. Or where there are dense hotspots, think, say, the Andaman and Nicobar Islands or the northeast of India, where there's perhaps more need for satellite capacity. More capacity will be aggregated there, and less so where it is not needed. This helps in reducing the overall improving the efficiency of the network, which means better cost economics, and obviously that will all pass down to the end user as a benefit. So that's one important aspect of how we've designed for affordable internet. And all the other points, I think Tony has well covered about coverage, about making it easy to plug and play, just like a fiber network. It's highly resilient because you don't have single points of failure. And of course, all of this has to come in a package which is affordable and lower cost than any other satellite network or even potentially multi-hop microwave network. This will be my I just have 2 more slides and then I'll hand over to Laura. As I mentioned, we are not focusing only on the space segment. We are actively working on an entire catalog of user terminals that users will have access to, and across a combination of technologies from dual parabolic to electronically steered antennas to hybrid terminals. But again, from a user's perspective, why are we doing this? Two key reasons. One, you would have access to the right terminal depending on what is the demand that you have. If you're serving a very small enterprise that has very low throughput, you go with a very small terminal vis-a-vis a very large terminal if you have big trunking links that are needed. But also we are focused on interoperability since our user link are based on Ka band, which is also the future SATCOM standard for high throughput, whether it is a large MEO or large GEO satellites coming up, including ISRO's future HTS satellites, which are Ka band to the user. So by building a terminal which is Ka band interoperable across LEO, MEO, GEO, from an antenna perspective, we believe it gives the end user more options in terms of which network they want to use, depending on the use case they have, and they won't have to spend extra to access different networks. We already have one LEO satellite for the last 2 years, which was launched on an Indian PSLV launch vehicle back in Jan 2018. And we've done a number of technology demonstrations. This is just a few examples of some of the players we've tested with. For example, we were the first ones to demonstrate 5G backhaul on a LEO satellite, on any satellite for that matter, with a total latency, round-trip latency of less than 20 milliseconds. And we are looking forward to conducting similar tests in India as well. And finally, the Government of Canada for their Universal Broadband Program have selected Telesat LEO specifically. We are the only LEO operator who've been selected to be the partner to bridge the universal connectivity gap in Canada, which coincidentally has the same future broadband standard of 50 Mbps to every citizen in the country. So, we're very proud of helping Canadians solve for it. I'll hand over to Laura from here.
Thank you very much, Manik. It may be easier if you continue sharing your screen, if you don't mind.
Sure.
I would just like to anticipate that my connection is unstable this morning, so in case it drops off, be ready. But fingers crossed. Before starting, I wish to thank very much Bharat, Arush, and of course all the other distinguished speakers and participants for this opportunity. So I'll start by talking about the spectrum, Ka-band spectrum used by Telesat LEO, both for the user terminals and for the landing stations that Manik already introduced. First of all, it's worth mentioning that in Ka-band there are 500 megahertz of exclusive satellite spectrum at the level of ITU table of frequency allocation, both on the downlink and the uplink. Referring to the downlink, the portion of the band 17.8 to 19.7 is shared with terrestrial services. However, the satellite user terminal is receiving in this frequency band, so it's causing no interference, and usually there are no issues with operation in this frequency band. For the uplink, 27.5 to 29.1 in the case of LEO. This band is shared with terrestrial systems. However, it's worth noting that there are provisions in the radio regulations for identification of portions of this band for use by essentially ubiquitous portable VSATs. In general, satellite operators really consider this band of essential strategic importance for the development of the most developed satellite systems. So in general, there is this they advocate for exclusive satellite allocation at domestic level in order to be able to deploy freely portable ubiquitous VSATs and eSIM and make the most of the efficiency and benefits of these novel systems. If we may go to the next slide, please. I've already mentioned at the prior event that there are significant regulatory developments concerning non-GSO eSIM in Ka band. Of course, there is WRC 23 agenda item 116. In Europe, just a couple of weeks ago, Europe finalized the revision of an existing harmonized European framework concerning non-GSO eSIM in Ka band, with the inclusion also of aeronautical user terminals. And while it is certainly true that Europe is Europe and other countries are different, I think there is merit in mentioning that the sharing conditions with terrestrial systems in the portions of the 28 GHz band that are allocated to terrestrial systems in Europe are actually identical to the sharing conditions for GSO eSIM. And this goes very much along the lines of what Tony already mentioned before. There is really, they will be studied for 4 years, but there is really no significant difference between GSO and non-GSO user terminals in terms of technology and also in terms of potential for interference. Also, the European decision is also based on the two principles that we consider very important, which are, and again, also Tony already mentioned this concept of blanket spectrum authorization for the user terminals, and also free circulation of user terminals based on mutual recognition of licensing and authorizations. For non-GSO eSIM in Ka band, there are already ETSI technical standards available in Europe, and these standards are widely recognized outside of Europe. When we come to domestic frameworks suitable for deployment, either they exist or they are being developed, and the regulators realize more and more the unfeasibility of individual user terminal licenses for user terminals that have the potential of being deployed in large numbers. It's also interesting to note that when we come to blanket licenses, there is no distinction between ubiquitous portable VSATs and land eSIM. In fact, if you take a 60 centimeter VSAT and you put it on a truck, then it becomes an eSIM. In practice, they are indistinguishable. At the same time, it's worth noting that a non-GSO VSAT operation is already, of course, fully covered under any FSS allocation. If we may go to the next slide, please, Manik, thank you. There are several aspects, more than issues concerning spectrum. It's very important to have a clear view of the availability of spectrum, both for user terminals operation and gateway or stations. And there is also a need for a clear policy for allocation of spectrum to satellite systems. I would like to emphasize that the allocation mechanism via spectrum auction is not suitable for spectrum that can be shared between different operators and potentially different services. Auctions would in fact lead to a terribly inefficient use of spectrum. An important aspect that has also been mentioned by my colleague Tony is spectrum cost. In fact, in the case of Ka band, high throughput systems can operate across 4 gigahertz of spectrum. However, the spectrum fees have often been set many years ago for much lower capacity systems, and they need a significant readjusting in order to make the business cases viable. We've already mentioned spectrum licensing, the need for blanket licenses. I will not emphasize these any longer. The aspect of spectrum sharing between satellite systems, I cannot but repeat what Tony has already said. Sharing with GSO, not an issue. For Ka, even in the portions of the band in which priority rules, compliance with EPFT limits is generally considered as a viable way forward. I also agree with what Tony said, that for sharing between non-GSO systems, excuse me, the best way is to leave to the operators to coordinate. There are ways to do so. Each satellite operator has a team fully dedicated to this task. Split spectrum should not be the first choice, because that leads once again to inefficient use of potentially inefficient use of spectrum. In any case, Telesat LEO is configured to comply with regulatory requirements. Manik already mentioned the System Resource Manager, this very clever software that carries out, amongst other things, also global coordination, including complying with frequency restrictions, for instance, via geofencing. So in other words, in every country we'll use only the spectrum that will be allowed to use. Next slide, please. LEO systems are relatively new in many countries, so there are other issues worth mentioning. One is, for instance, the licensing of landing stations, that in the case of Telesat LEO comprise from 8 to 14 full motion antennas of around 4 meters each. We'll deploy at least 2 of them, planning to deploy at least 2 of them in India. Each antenna is tracking, of course, a different satellite, but the range of pointing angles and the frequencies that are used by each antenna are the same. So in other words, there are multiple antennas on the same site, but there is a replica of the same antenna. And in terms of spectrum denial, additional interference, the effect of the additional antennas is negligible. As such, we advocate that a single license would apply for the multiple identical antennas in the same area that operate within the same satellite system and use exactly the same spectrum. Another issue is the possible, specific to India in this case, is the possible requirement for an interface requirement document. This has already been mentioned by Mr. Srivastava at the very beginning of this event, and I understand that there are already the developments on the current documents in terms of simplification and alignment. So I'll be looking forward to seeing the new version of the document. There may be a requirement for an equivalent one for non-GSO. Finally, just mention some issues for possible consideration in relation to the unified license framework. I understand that there is a larger review that is ongoing that may also encompass this aspect. The unified license framework is a very extensive framework. At the same time, it's also a very complex one. So just questions for consideration. So for instance, are the different categories still adequately reflective of current technology? Is there scope for simplification without, of course, detracting from safety and security? Again, just questions put on the table for possible consideration. If we may go to the next slide, please. This is the last one, but by definitely not the least. the least important one that concerns space policy. There is a lot of work ongoing at the moment, and Telesat very much welcomes the initiatives by the government of India, Department of Space. There has been a very recent consultation, and Telesat, together with other operators, was most pleased to see provisions towards establishment and utilization of non-GSO communication systems. There are several points that may need further clarification, but just I'll highlight some of what we consider the main ones. We believe that it's very important to distinguish requirements between establishing and utilizing a satellite communication system that may in turn lead to different requirements for the Indian entity. Concerning the Indian entity, also this aspect may need additional clarification. Our preliminary understanding is that the Indian entity only utilizing a foreign satellite system to provide services in India can be a local provider, of course, with the required category of unified license. In general, in order for the space policy to be implementable, we believe that there is a need for a more extensive, a complete harmonized policy covering all aspects related to satellites, which are also licensing, spectrum, and the space segment. I would like to touch two final items that we still believe are very important. First of all, we humbly believe that the DOS should look to evaluate proposals for authorization on general merit and not be a part in the commercial contract between the satellite operator and the licensed service provider in India. Also, foreign companies should be encouraged to operate. This will lead to healthy competition in the sector, to an improved choice that cannot but be beneficial to the customer and ultimately to the country itself. In any case, Telesat, together with other satellite operators, much appreciated the opportunity to comment on this very important consultation. If we may go to the final slide, in fact, which is just the conclusions. So there is no doubt that state-of-the-art non-GSO systems are coming to the market. They really have the potential they will be complementary, of course, to the existing GSO, but at the same time, they really have the potential to truly revolutionize provision of affordable connectivity with high speed, low latency for a true fiber quality experience. In order to do this, Telesat is promoting a competitive and innovative marketplace, which we believe this is essential complement for the deployment of this system. And for this to happen, there needs to be a complete and harmonized policy, regulatory policy, covering all aspects. And with this, I would conclude the presentation, and thank you all very much for your time and attention today.
Thank you, Manik and Laura. Excellent coverage of the Telesat system and the benefits that it can provide to all the economies. Great for you to have covered both the business aspects and the technical aspects and the spectrum aspects. So thank you very much, and hope we all stay engaged. Telesat has great engagement with the ITU-APT Foundation of India and with India itself. Manik being there in Ottawa itself is a great example. So we will continue this engagement. So we now have about half an hour, a little less, for some discussions and comments and questions. But before that, I want to see if Dr. Badawi is still there. I want to invite him to say some comments. Dr. Badawi, His Excellency, was chairman of the WRC 19 and very successfully managed a very difficult conference. So I'm inviting Dr. Badawi to the screen, to the stage, if he's there still. Yes, I think he's there.
Well, good afternoon, everyone. Thank you, Mr. Bhatia. I'm honored to be here and to hear such distinguished speakers. And I learned a lot today actually by listening to the presentations that were given by Mr. Azarelli and uh, Ms. Laura and Mr. Manik. I'm missing the days of the WRC 19 because to me it was an excellent experience where I was able to we were able to reach very successful conclusions for all industries. I believe we had a very good chance that we were at a junction where we were having much more spectrum being availed for all the industries. And I think if we can continue with the spirit of cooperation and integration, which I see is, I can feel it from the speeches that I heard today, that all technologies are needed if they are integrated together. They will result in very good advancement for the telecommunications to provide connections for the unconnected at reasonable prices that they can afford. And I can say that the COVID-19 has shown the importance of having everybody connected. And I think where countries that did not have connections, people suffered a lot, having uh, trouble getting education and proper health care. So I believe the role of the non-GSO satellite technology will be extremely important. And if we can integrate it with other technologies like Wi-Fi and, of course, IMT technologies to provide a complete network for everyone, I think we will be successful. Of course, I think we are charting new territories for some of the regulatory aspects, as I can see from the speech of Laura and from Tony. I hope that we will be able to get through that. I think WRC 23 will be another step forward. I think that the satellite technology has evolved quite a bit in the past, maybe 8 to 10 years. I'm hearing very, very impressive uh, technical specifications for the LEO satellites. A lot of enhanced capabilities that will help us go further. And I wish you luck. I can see that India is pushing forward now with their involvement in OneWeb, and I wish them luck in and success in pushing this venture forward for their benefit and for the benefit of other parts of the world. I know India has been, has been quite involved in undersea cables, which is another important part of connecting the world. Thank you again for giving me the chance to speak. Uh, I'm sorry I did not prepare for it. I was just surprised when you said that you're going to give me that chance. But I really enjoyed this session, and I wish you the best in the rest of the session. Thank you.
Thank you very much, Dr. Badawi, and thank you for all your hospitality in Sharm el Sheikh, where we spent a good amount of over a month. Are there any questions or comments in general? I'm just please raise your hand. There's a raise hand icon on the right side of your screen if you have any question or comments. Otherwise, I'm going to invite Mr. N.K. Goel to make concluding remarks and vote of thanks. Okay, since I don't see any hands, over to you, Mr. Goel.
Yeah. Thank you very much. I
I'm very happy and very proud of our team of ITU-APT, Mr. Bharat Bhatia, Mr. T.R. Dua, that within the allotted time and one of the rare conferences in the video online, we are moving second by second as per the agenda. So 3 cheers for our organizers and 3 cheers, and thanks to our honorable VIP speakers, Mr. U.K. Srivastava, Laura, whom we know now so much that it looks as if she is in India, Dr. Tony, Dr. Manik, and I am surprised there are more than 90 delegates in the conference. The topic was very relevant, not only for India but for the world, because unconnected citizens is a problem worldwide. Even though we have lots of technologies, lots of answers, lots of money, lots of operators, the problem remains in so many areas of the world. And with COVID-19 post era, everything online, the problem is more acute, more severe. We are facing now more digital divide in terms of urban and rural, in terms of affordability. And we are very happy for this conference organized by ITU-APT for non-GSO satellites. Our special compliments also to Bharti Group for OneWeb. And if Mr. U.K. Srivastava is here, for the first time, our government has formed 6 working groups for 5G applications. So I just each and every officer will delegate for the thanks a lot.
Thank you, Gold Sahab. It was indeed good for you also to attend. I know some of the speaker did mention that there is a possibility of manufacturing in India, and so hopefully TIMA will have a role to play in the coming years once the policy guidelines are cleared. We will continue to work with the TEC, with the DOS, with the DOT on how to move forward on this new policy development. And if you have, or any of you have any suggestions, perhaps it will be good for all the LEO entities to work together and work with us so that we can put together a common front to the government. So with that, I think we have come to the end of this great event. Thank you particularly to Mr. Dua, Mr. UK Srivastava, Mr. Tony Azeli, Mr. Chris, Laura and Manik, and Mr. Goel, and also to Dr. Badawi, who just happened to be here with us, and it was good to have him back here on the stage. So with that, we would conclude this session. The presentations for this event will be available on our website, which is itu-apt.org, and you can download those presentations from there. We would also be having another session coming up shortly in terms of V-band and other Wi-Fi related technologies. There are some issues relating to those bands, and I think we will shortly come up with the details of that program. We are also working on a program on 5G spectrum auction fees. I think 5G spectrum is overdue in India, and there are some challenges with regard to the reserve price for the 5G spectrum in various bands. So we are working on that, and hopefully we would come up with a short discussion on that as well. So thank you all for joining, and hope to see you sometime soon as Geneva opens. Take care.
Thank you very much. Thank you.
Thank you very much.
Thank you.